Day 764 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. In the day, we have question number 1539, kth missing positive number. The difficulty level is easy, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out this link in the description so you can get you some. Now let's see what the question says. Given an array R of positive integers sorted in a strictly increasing order and an integer k, return the k positive integer that is missing from this array. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input R equals an array of integers 2, 3, 4, 7, 11, k equals 5. That means we want to find the fifth missing number from this array. The output is 9, right? Then the explanation says the missing positive integers are 1, 5, 6, 8, 9, 10, 12, 13, and so on. The fifth missing positive integer is 9. So to break this down one step further, as you can see, we have this array of integers right here. These right here are all the numbers missing, right? So we're missing a 1, then it goes 2, 3, 4. We're missing a 5 and a 6. Boom. Then it goes 7. Then we're missing 8, 9, 10. Then it goes 11. Then it goes 12, 13, and so on, so on. So these are the missing numbers right here. We want the fifth missing number. So we go 1, 2, 3, 4, 5. 9 is the fifth missing number. So we return 9. Now, just in case that didn't make sense to y'all, let's take a look at example 2. So in example 2, our input R equals an array of integers 1, 2, 3, 4, k equals 2. The output is 6. Explanation says the missing positive integers are 5, 6, 7. The second missing positive integer is 6. So in this case, you can see this is kind of like a trick question because just from looking right here, it looks like there are no missing numbers, right? It goes 1, 2, 3, 4. So since we have all these numbers, the missing numbers include, as you can see, this ... means these missing numbers could go on for infinity, right? So since we have all of these numbers right here that are not missing, we just continue going down the line, and we go 2 more down the line because k equals 2. So we go 5, 6. We land on 6 because 4 plus 2 is 6, and there's no missing numbers right here. Boom, so the output is 6, y'all. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, the first thing we want to do is, let me see, give me a second, y'all. How do I want to solve this? Let's see. So we're going to use a binary search. That's how. So first thing we want to do is we are going to search for the first position where the number of the missing positive integer is at least k. So hold on, y'all. My computer's about to die. Gotta get a charger. All right, we're back. Boom. So first we're going to declare our boundary. So we're going to declare a variable called left, set that equal to 0. And we're going to declare another variable called right, and we're going to set that equal to r.count. Boom. Then we're going to say while left is less than right, we're going to open up the brackets, and we need to get the middle index of the current search range. So we're going to say let mid equal, open up the parentheses, left plus right. Come outside of that, and we're going to divide that by 2. Boom. Now we need to calculate how many positive numbers are missing before mid. So we're going to say, come underneath this, we'll say let elements missing equal r square bracket square bracket mid, come outside of that, minus mid minus 1. Boom, and if fewer than k numbers are missing before r mid, then the kth missing number must go to the right. So we'll say, come underneath this, and we'll say if element missing is less than k, We're going to open up the brackets and we're going to say left equals mid plus 1. Boom. Otherwise, the kth missing number is at mid or somewhere to the left. So we come right here. We're going to say else. We're going to open up the brackets. We're going to say right equals mid. Boom. And then after the binary search, we just need to return the answer that is obtained by adding k missing numbers to that position's offset by coming down here, and we just have to say return, k plus mid, y'all. Boom. That should be all she wrote. That's our binary search function right there. Let's go ahead and give it a run. Make sure it runs properly, and it does not. Cannot find element missing. Oh, let's get rid of that S and run it again, y'all. Hopefully that did the trick. Boom, let's see. Okay, cannot find mid. Okay, so let's see. Oh, sorry, y'all. This should be K plus left, y'all. Sorry about that. Boom. Let's run it again. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, make sure you get one more look at the code. And I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.